collaborative ontology. Okay, recording in progress. Using our collaborative ontology development model, which is comprising both processes, governance framework, and hardware and software components. We focus on standards ontologies and the DAL platform, Data Innovation Lab platform, that I've just described, which is a combination of the hardware, software, infrastructure, and processes and governance framework, basically results in producing vendor-agnostic open source models. Some of the projects that we will be talking about briefly today is basically starting historically from FIBO, Financial Industry Business Ontology, which the work started probably 10 plus years ago. Pharmaceutical industry identification of medicinal products ontology. Automotive, less so because it's a small piece of work. Some government work that we have done for NIST, National Institute for Standards and Technology, and an ESG-related piece of work that we have done for COP27 last year. Basically, what we are doing, and by driving this collaborative model, results in reducing costs and implementation effort because it's collaborative, and it dramatically drives industry adoption and reduces time through or development time through achieving faster consensus. And probably Elisa will also talk about that. So I will not spend too much time on this slide because it basically says that yes, we do have the expertise. We bring together some of the best ontology brains in the world. Elisa is one example. For those interested, she wrote an extremely interesting book called Ontology Engineering, co-authored it, and it's a very good read. So we bring excellent people, the governance model and infrastructure components, both hardware and software, and we've been doing that for a long time. Starting with FIBO, and Elisa, I'd like you to speak to this slide loosely because it is relevant for this group. I will then dive into EDMC. But one of the aspects that might be of interest is the recent article from our friends at Data.World regarding using knowledge graphs in conjunction with LLMs and so on. Can you give us your quick perspective on FIBO, please?
Well, so FIBO started by other folks at the EDM Council after the meltdown in 2008. It was originally a spreadsheet with terms and their definitions that were intended to help bridge some of the gaps where many people in the industry use the same terms to mean different things or use different terms to mean the same thing. And there was an impetus from the Basel III and other regulations coming down the pipeline to try to coalesce around some common definitions, especially for regulatory reporting. And so FIBO was kicked off to address some of those challenges. In about 2013, it was converted to the Web Ontology language, which is the ontology language we use for specifying the ontologies that we've developed at the lab. The Web Ontology language goes back more than 20 years. Many people think OWL is new. It's not. I was on the committee in the late 90s to develop the language, and so it's been widely used since, along with the framework that it builds on, including the resource description framework. OWL ontologies have been notoriously ill-adopted, fraught with lots of issues. Many ontology projects fail for a wide variety of reasons, one of which is lack of use cases, lack of scope, lack of competency questions in order to ensure that the ontologies actually are able to address the requirements that they were designed to help solve. and so on and so forth. And yet another piece of the story is the requirement for quality management. And many projects have been started by academic teams who only have funding to go so far. So maybe they have a lot of breadth, but not a lot of depth, or only depth in a few places. FIBO is different, as are the other ontologies we've developed at the council. And the primary reason for that is we're very strict about use case driven approaches. We use competency questions, which are the questions that you want the knowledge graph to be able to be asked and to answer, with sample answers, so that we can do regression testing to ensure that the answers we get back are consistently what we want, and that changes don't break backwards compatibility. And so that whole process has been implemented to a large degree in the infrastructure that the lab provides, based on a lot of years of testing and collaborative work on FIBO from not only us, but colleagues that have also contributed. The main areas of work include coverage for securities master data management. We've been integrating other features from FPML, from the common data model, from various ISO standards and other sources. We have excellent coverage of the CFI standard, and we're continually updating the reference data that we provide in order to make it useful for folks. And now we're expanding into other use case areas beyond securities master data to look at exposure and risk in various areas. And there have been projects by some of our users with respect to know your customer. A very large bank based in North Carolina did some work a few years back with testing parts of our model with understanding the relationships, ownership and control, beneficial ownership, affiliation, and other things like that for over 5 million wholesale customers, in order to see whether or not we could actually address some of the KYC questions they were being asked by the regulators, which we were successfully able to do. And so since we, I guess in the last 2 or 3 years, we've started looking at patterns inside the ontology and where we can leverage those same patterns to gain acceleration in other projects. We've spun out a number of the core patterns from FIBO into standards that have now been standardized at the object management group, and then we backfill FIBO with the updates. And those standard ontology components like Lego bricks have been the basis for work we've done on IDMPO and other ontologies we'll talk about, where we believe we saved more than a year's worth of development time on the pharma project by reusing those patterns, and where it's my belief that not only does that make the ontologies higher quality and more accessible to our user community because the patterns are recognizable, but it also provides lift with respect to machine learning and the use of either custom language models or large language models that can also recognize those same patterns, and then be able to accelerate development by having the models themselves predict additional information that might be something we would want to add, or at least use those same patterns as the basis for new kinds of applications and inferences. So,
Lisa, I want to interrupt you just for a second to underscore what you said, because you've said a lot, and that's a really important point that might not be fully appreciated, that FIBO as a resource was extensible beyond application to financial instruments in a very powerful and meaningful way. And so these resources are much more applicable than you can possibly imagine. So once you start to kind of get on the path of utilizing something like FIBO, it's got not endless possibilities, but certainly possibilities that were pretty impressive, right? Because you're talking about the medical device, or it was a medical, not the medical device, it was molecules. Like how would you extend FIBO into that space? And I think you had some statistics like 56% of FIBO was reusable and applicable to.
Well, 56 to 75, depending on how you look at it, percent of the work that we did on the pharma project, which I think we should skip forward to, because Jan, I've only got 5 minutes. So the roughly between 50 and 75% of the work that we contributed to the pharma project was based on the patterns that we lifted from FIBO.
Yeah, that's pretty impressive to me.
That's what we mean by saying that we have 10+ years experience. It's not just building FIBO. It's building the baseline for all other work that we are doing.
Yeah,
and it really speeds things up.
Yeah, and the really interesting thing, and Elisa touched on this, we're going to talk more about it in a second, is how a knowledge graph / ontology can be leveraged with large language models, AI, etc. And I sent out the research piece to everyone on the steering committee, but we can talk a little bit about that as we go on with this. Great.
Well, Elisa, if you want to comment on this, please do, because unfortunately, Elisa needs to drop in about 5 minutes. We have a conflicting IDMPO release management meeting. We're releasing actually version 1 of the IDMPO ontology by the end of the year, and it's pretty intense. So apologies for that.
Yeah. So
hey, Jan, can we also just get a perspective, Lisa, of the 56%? Because it seems foreign to me that from a FIBO perspective, it would correlate into pharma. So just if you could touch on that before you drop as well. That'd be
yeah, I
helpful
can really quickly. FIBO was built essentially top down, which is not necessarily my recommendation these days. What we did for pharma has been far more successful, but in part because it built on some of these building blocks. The starting points for FIBO included what the folks that came before me originally called foundations. It included defining things about people and organizations and addresses and time and a place, a general entity kind of relationships, and a number of those we've stripped out. Over time, I added a number of standard patterns for things like representing identifiers, representing codes and code sets, controlled vocabularies, classifiers and classification schemes, many of which are derived from other ISO standards. I've also added a party role model that's situational, that is time-bound, that is what we leveraged at this very large bank with respect to know your customer. That pattern is now repeatable. It's embedded in the work that we're doing in pharma for relating pharmaceutical products to the substances that compose those products. And so there are a number of things like that that are sort of Lego bricks. In pharma, you have a gazillion identifiers for a given substance, and often competing identifiers for things with the same name but are not quite the same substance, where it comes down to the molecular structure in order to differentiate them. The same patterns that work for identifiers for financial instruments work for identifiers for substances and things like that. So those are really the kind of, I'll call them Lego bricks, that we use to build up a lot of the patterns under the hood. Those same patterns are extraordinarily clean, recognizable, and no longer ad hoc in FIBO or in any of the other ontologies we build at the lab. And therefore, because we're rebuilding on these Lego bricks, the pattern matching algorithms embedded in machine learning or in natural language processing, which is what drives large language models, can recognize them.
Okay.
All right, Jan, last minute.
Last minute. Okay. an opportunity to ask one final question to Elisa.
Well, I was gonna the business case or example that you described in another meeting that I've been in with you, Elisa, about how they've used the ontology in a meaningful business sense. I think it was a safety issue, a recall or something like that.
Well, yeah, so that was for IDMPO. Maybe Jan skip forward to an IDMP slide so that it makes a little more sense.
There we go.
Okay. So the problem is that there are a bunch of different ISO standards that are ambiguous. And so a bunch of pharma companies have implemented them differently, as you might guess, as have the regulators. And one of the companies participating in the project was notified by the regulators that there was a toxin in some product they produced, which caused somebody to either become quite ill or possibly to pass away. I don't know how severe it was. I just know it wasn't good. And they needed to recall any product that included that toxin. And they knew which drug the individual had taken. And so they dug through all of their manufacturing documentation, all of the processes and systems, and could not figure out where it came from. And then, you know, they started looking beyond just the substance itself, whatever drug it was, but to the manufacturing process, and discovered that that toxin was in the packaging and it had leached into the drug. And it took them 60 days to unwind that and to figure out what other products they needed to recall that might have the same issue. And 60 days is a long time when you're talking about people's lives being impacted negatively by that. And so now, using the IDMP ontology, that was our first use case, using the ontology, they can answer that question in a matter of seconds. And with that, unfortunately, I need to go.
Thank you,
So
Elisa.
Thank you,
thank
Elisa.
you very much for your attention. I'll look forward to the next time we get together.
Cool.
Thank you,
Elisa.
Elisa. See you soon. So let me continue. This was actually a great example of what are the benefits of an ontology properly modeled and built. Lisa described the situation here. Basically, what we are doing for the IDMPO project is transforming a PDF-based set of ISO standards into an ontology, which now provides a common language and bridges the gaps, any gaps between people, processes, and systems, as illustrated on the right-hand side of this diagram. So so now on to really interesting stuff about how we deliver projects like that. This picture basically defines our collaborative ontology development model. And you can, I'll walk you through this relatively quickly. The most important box here is the project steering team, because you can see all the contributors or participants or members or sponsors or funders of the project. All these names actually apply. These are head-on competitors on daily basis. However, in this initiative, IDMP ontology development, they sit at the same table. Every 2 weeks, we have a project core team meeting, which brings together subject matter experts, where we actually progress with the ontology. We discuss definitions, we discuss relationships between different concepts in this knowledge model. And we work together hand in hand to build the ontology. You then have the sort of project delivery layer, which is bringing together ontology governance and hosting, ontology development, use case implementation, and use case specification and value capture. All of these 4 boxes are fundamentally important to the development of an ontology project. The nice thing about it is this is a collaborative development. So we have all these pharma companies, 11 of them, working together, but the project is open. So the resulting ontology is an open source, publicly available ontology. Obviously, the use cases. So in other words, the direction within this particular specific standard that we model in the ontology, the definition of the use cases is depends on what this group of contributing companies want to do. So it's in their best interest to be part of the project, because that's how they achieve their own competitive advantage and regulatory agility and so on and so on. But we also do every 2 months. We do a project community of interest meeting, which is open to everyone, anyone. This usually brings together 200 people, 150 people, and we basically report on the progress of the project, where we are going, what are our ambitions, and so on and so on. On the right-hand side, you can see that we also work with regulators, standards development organizations, and other entities. I will not get into any details, but the interesting point about this is that this project is about transforming ISO standards into an ontology. So ISO has been more and more involved, in the sense that they were observing the progress and listening to the feedback they are getting from the industry. And they got so excited that at some point they decided that EDMC ontology should become a formal technical specification of their standards. And this is an internal effort they have undertaken officially in ISO, and we are very proud of that. So the benefits to all these sponsors. Yeah.
Before you get into that, there's a good question in the chat. When you're engaging with these companies for their different use cases and projects, what are the types of folks that are being brought into that discussion? Are they data modelers, like metadata folks? Are they engineers? What's the cast of characters within these organizations that are working with you?
Mostly it's subject matter experts who are experts in the fields related to the use cases that these players want to be addressed.
So with molecules, you had scientists.
Yes. Chemists, biochemists, vaccines experts, not ontology. There are some people who are also knowledgeable about ontologies, but the role of the pharma companies, the role of the sponsors is not to develop the ontology with us. It is to drive, is to feed us with knowledge and expertise that can help us develop the ontology.
But I would imagine you then do engage with the technology folks once you get past the ontology and actually.
Yes.
Yeah.
So one part of this effort is it's a normal project, right?
Mm-hmm.
So we first of all, once we have the group of potential or interested or declarative sponsors or contributors to the project, we basically put together a statement of work. The statement of work contains all the work packages. It defines the budget of this for this exercise, and it specifies how the overall budget will be split between the different work packages. One of the work packages is our support for in-house private implementation of this ontology for each and every one of these of the project members, the pharma companies. We are not doing the full implementation because that requires many months of effort. It's a large project normally, but we get them started. We provide guidelines for how they should be thinking about implementing this ontology. We run workshops with them. We answer their questions. We basically point them in the right direction and then provide support on as needed basis if they need any steering or guidance.
Got it.
And that is one of
Hey-
the things that is highly valued by all the project members.
I just want to pay attention to time too. How much time do we want to give before wrapping this up, Mike? So we can.
Well, I think we can, if Jan can quickly go through,
I can.
yeah, and then we'll have a, a discussion just to
Cool.
try to connect the dots, talk about how we can potentially apply this to our group and financial market data, et cetera.
Yeah. So let me go through this really quickly. It's a big topic, so apologies. There are obvious benefits, and I'm not going to read these points. There are use cases that you define as a potential sponsor. There is close alignment with regulators. There is faster, cheaper, and more efficient development, and so on. So, this is just an illustration that each of these companies actually have a planned use for this ontology in mind. So it's not a theoretical exercise for the greater good of humankind, although at the end of the day it is. But they have specific plans to actually how to use the ontology in-house to achieve competitive advantage. Next, this is obviously not the only one that we are doing. We have just recently completed a project for NIST, helping them build an infrastructure and a governance model to develop multiple ontologies for the manufacturing industry. This is a piece of work that we have done for COP27 last year about reconciliating standards around greenhouse gas reporting. As you all know, there are hundreds of these standards depending on geographies, regulatory regime, and so on and so on. The point is, what I have showed you is a replicable project delivery model. So it works for EDMC. It works for another initiative that is under construction, so to say, about operational resilience. It works also for the communications industry business ontology that we are working on, and possibly some others that are at an earlier stage. And that's really it. So I'm done. Back to you, Michael.
Yeah. So obviously very interesting, and I think potentially very relevant for what we can do with our special interest group. And I believe that an initiative like this can potentially be used to facilitate data connectivity in our industry, standardization of data, and also potentially leveraging AI with this. In fact, Jim, I sent out that research piece, which I thought was extremely interesting, by the way, on the use of knowledge graphs with Gen AI. Do you want to, Jim, just point out a few things that we spoke about earlier of what?
I do. I'm just looking for the document here to pull it up. I've got so many things open.
I can bring it up if you want.
When I went to share it.
Yeah, hold on a second. I can bring it
just
up.
a plethora of.
That's okay. Here we go.
Let
me bring it up here. Okay, so.
Oh, yeah. All right.
This is the research paper that I sent out to everybody.
Yep.
And basically it was a study of how large language models like ChatGPT-4 can be significantly enhanced with the use of a well-defined knowledge graph or ontology. Okay.
Yeah, so if you jump to page 8,
right.
Yeah, so the setup is like, we all know that everybody's trying to figure out a way to use these large language models effectively. And we also know that these large language models produce a lot of BS. And so how do you improve the quality of the output? And you know, my mantra is knowing trumps guessing any time of the day, any day of the week. And that's what, you know, if you have an ontology, you've structured what you know. So what they did here, and this is not the only way to use these things. This is just a kind of a simple, straightforward example of, hey, let's look at what ChatGPT does if you use it against your SQL databases. And you know, if you ask ChatGPT a question, it's trained on your own data. And then let's compare that to, and go to page 9. Let's compare that to having ChatGPT then talk to a knowledge graph that represents the space, the question space, if you will. So that's on the next page. So you can just see the extra layer in there, the ChatGPT-4, you know, you're still asking a question, it's going to ChatGPT-4, but then now there's an extra layer where it's been designed to run that up against an ontology of the question space or the knowledge space. And the result is, if you go to the table, there you go. You know, huge improvement, right?
Right.
So without the knowledge graph, all the questions were 16.7% accurate, and with the knowledge graph, it was 54.2% accurate. Now, you know, we want 100% accuracy. I think that there are other ways, more meaningful ways to utilize knowledge graphs with LLMs. This is just something that anybody could do very simply in their own environment. You know,
Yeah.
and it's certainly better than just you know. But we already know that organizations are already trying to run train their GPT-4s on their own data. And the truth is that without having something like a knowledge graph, you're going to have to do a lot of fact checking.
Yeah. And also I should mention, last week I chaired the Phil's Connect conference in Charlotte, which was 60 plus heads of trading in the asset management community. And we had a breakout session to talk about Gen AI and data governance, et cetera, et cetera. And we talked about this a lot. You know, how the industry could potentially leverage machine learning, AI, you know, what are the data governance issues around that, et cetera, et cetera. So I think and there was actually an article that was out yesterday or the day before, you know, regarding Gary Gensler and the SEC asking questions of investment managers about their use of AI and data governance, et cetera, et cetera. So I think that this is very relevant for that. So just wanted to mention that as well.